Okay, good morning class. So today we're looking at the last part of exponents. We're going to look at scientific notation today. Okay. So scientific notation is exercise 4. Is that correct? And exercise 4 is on page should be page 18. It's page 18. The examples are also on page 18. Okay. So we are told that scientific notation is a convenient way of notation to express very large or very small numbers. Okay. Scientific notation requires one significant non-zero digit in front of the comma. Okay, so we'll make some notes after I explain this, so it's just going to explain it, otherwise the video is going to be too long. Okay. So let's look at example 1. Okay, the question would say, write the following numbers in scientific notation. Okay, write the following numbers in scientific notation. So what is the rule? The rule says, scientific notation requires one significant non-zero digit in front of the comma. As it stands here, we have a 0 in front of the comma. So one significant figure, the first significant figure would actually be 3. Can you see here? So this comma actually will lie here. Okay? Which means to say I'm moving this comma how many units? 1, 2, 3 digits. Or 3 decimal places. Not so. So when I write this number out, I say 3,18 multiplied by 10 to the negative 3. So if you move the comma to the left, okay, then it will be negative on the exponent of 10. Not so. Which means to say if I move it to the right, the exponent will be positive. So you can make that notation. Okay. So if the comma moves to the left, the comma moves to the left. Sorry, that was actually right. No? Comma moves to the right. It will be negative on the exponent of 10, and if the comma moves to the left, then it will be positive number on the exponent. Okay. So if the comma moves 5 units to the right, then it's going to be times 10 to the negative 5. If it moves 12 units to the right, it will be times 10 to the negative 12. If the comma moves 4 units to the left, my left and right is not the left. 4 units to the left, it will be 10 to the power positive 4. If it moves 20 units to the left, it will be positive, 10 to the exponent, positive 10. You guys understand? Alright. So yeah, the sum was must write 1, 3, 4, 0, 1, 2, 3, 1, 2, 3 in ordinary and in scientific notation. When you see times 10 to the 8 times 10 to the minus 2 times 10 to the 4, then that is your scientific notation. You guys understand? Who can say this number? What is this number? 1 trillion is 340 million. Not trillion, that's billion. No? What is more, billion or trillion? Billion. Trillion is more. So that's actually 1 billion 340 million. No? Some of your bank accounts is going to be this. No? Right. People, I don't see any comma there. So where is the comma currently? If I must put a comma in, where's the comma? There. Yeah, and the last zero. Because if I write 5 in fraction form, it can be written as 5 over 1. If I write 5 and I ask you to write it in decimal form, it will be 5 comma 0. You will understand it. So, well, if there's no comma, we know the comma lies there. Where should the comma be? Behind which number? First. Why? Because it must have one significant figure. Can you see that, people? So the comma must move here. Okay. So let's move the comma. Whoops. That is not the comma. So let's move the comma. So it's here, no? If I move it here, it's going to be 1, 2, 4, 5, 6, 7, 8, 9. Can you see? So in other words, this number is actually 1, 3, 4, 0, 0, 0, 0, 0, 0, 0 times 10 to the 9. Positive or negative? Positive. Why? Because I moved to the right. Now, if we tell you, you got 1, 2, 0, 0. We need to simplify that. Or write it in a simpler form. What would it be? 1 yes, comma 2. I don't need to keep that. Why? It doesn't have any place value. It's at 0. However, if I had 1, 2, 0, 1, can I drop the 0? No. Okay, because of this 1. So do I need all the zeros here? No. I can simply write this as 1, 3, 4 times 10 to the exponent 9. Okay. Let's see what they say here. You got arrow 1, arrow 2. Comma is moved from arrow 1 to arrow 2. That is 9 places. Again, if you move in the comma from this point, from right to left, positive. We're moving from left to right, negative. Okay. So remember that, no? So let's look at this here. Now they want you to write this number in ordinary form. Okay. Now we want to write it. This is what you call scientific notation, not so. So now that is now positive. But when we write it in ordinary form, the rule is in swap now. Not so. So this comma must move 4 units to the right. Can you see that, people? Now in reverse. No? Earlier on, when it was positive, we needed to move the number to the left, no? To write it in scientific notation. However, from scientific notation to ordinary form, the roles must now be reversed. Okay, so what would it be? So what I do is I just add a few zeros here. If I add zeros, do I change anything here?
No.
No. So that is times 10 to the 4. So how many units am I supposed to move the comma by? 4 units. So let's move. 1, 2, 3, 4. So do I need this here? No. So what is the number? 1, 2, 5, double. So 1,25 times 10 to the 4 is the same as 12,500. Then we can test it. Okay? So it's going to be 1.25 times 10 to the exponent, negative 4, at 4. Okay, so that is 12,500. Any issues there? Any confusion? Any questions? Alright, okay, we'll do another one. I'm moving too fast. People number 4. We got 5,068 multiplied by 10 to the minus 6. So which way must the comma move now? To the left. Okay. So if I add a few zeros in front of the 5, this will now be the left. 0, 0, 0, 0, 0, 0, 0. So add some 6 zeros. 5,068. Okay, times 10 to the minus 6. That means to say I must move the comma 6 units. Can you see that, people? So it is the comma currently, no? So I'm moving it. 1, 2, 3, 4, 5. Can you see that, people? What do I write now? So this is equal to 0, comma. How many zeros are here? 5 zeros. Okay? 0, 6. That's 4. Okay? So let's have one more 0 here. 1, 2, 3, 4, 5. Yeah. We move it 1, 2, 3, 4, 5. Yeah. Now, do you guys understand? I don't think the calculator is going to give us the answer like that. But let's see, 5.068 multiplied by 10 to the negative 6. Okay, so we want it in ordinary form. We play shift engineering. There we go. So 0, comma 0, 0, 1, 2, 3, 4, 5 zeros, 5,068. People, anything to the power 0 is 1. So that 10 is actually 1. You guys understand? Any questions? So now we'll move a bit slower, okay? Now, calculations using very large or very small numbers can be simplified without a calculator by using scientific notation and laws of exponents. Okay. Okay, so here in this example, we got 2 multiplied by 10 times 4 multiplied by 9.1 multiplied by 10 to the minus 8. So what I would do is, I would say, let's look at this here. If it was 2 multiplied by x, if 10 was the x now, 2 multiplied by x4 multiplied by 9.1 multiplied by 10 to the minus 8, or x to the minus 8. What would you have done here? Like terms. The x's are the same basis, no? So that will be x to the exponent What's 4 minus 8? Negative 4. And 2 times 9.1 times 2 is going to be 2, 18. 18.2. Not so. So it's 18.2 times 10 to the minus 4. You will agree with that? Why could we have done that here? Because the basis was the same. Now with that in mind, let's do this one here. What's 9.1 times 2? 18.2 times. When you're multiplying and bases are the same, what do you do to the exponents? You add. So it will be 10. What's 4 plus minus 8? Negative. Okay. Now, because this is scientific notation, your answer should conform to the rule of what scientific notation is. And what scientific notation? Scientific notation requires one significant figure other than 0. Not so. In front of the comma. Is that the case with 18.2? No, it's not. So if you got 18.2 and you must write 18.2 in scientific notation, what would it be? 1.82 times 10 to the? Would it be negative 1 or positive 1? 1, positive 1. You will agree with that. Why? Because we're moving the comma to the left. We're moving the comma to the left in scientific notation. Must be positive. Not so. That was the rule we made earlier on. When it moves to the left, the exponent must be positive. Okay. So with that in mind, summa. Right. So 18.2 can be written as 1,28 times 10 to the 1 multiplied by 10 to the negative 4. Now what? Here we go. When we're multiplying and bases are the same, add the exponents. You guys understand? So this will simply be 1,82 times 10 to the negative 3. Okay? So let's go through it again quickly. We multiply the ordinary numbers first. Okay? So 2 times 9.1 is 18.2. 10 to the 4 times 10 to the minus 8. Since the bases are the same, I can multiply, add the exponents. 18.2 is not in conformance with what scientific notation is. So we change that to scientific notation. So it's going to be 1,82 times 10 to the 1, because I moved it 1 unit to the left. Since now we notice that the bases are the same, I multiply, add the exponents. So 1 plus minus 4 is negative 3. And we can test it, people. We can say 2 multiplied by 10 to the 4 multiplied by 9.1 times 10 to the negative 8. Okay, now of course you're going to put in engineering mode, which is 1,82 times 10 to the minus 3. Okay. We will probably do only that part today, and then tomorrow I will give you an exercise on this, okay? But just for the video's purpose, I don't want to make too many small videos, so I'm just going to do it in one, okay? It looks a bit confusing for you guys, I can see it on your faces. That's fine. Let's look at the next one. Here we got 1,05 times 10 to the minus 2 plus 3,8 times 10 to the minus 3. Now again, if I replace x with a 10, so it's 1,05 times 10 times x to the negative 2 plus 3,8 x to the times x to the negative 3. numbers like or unlike terms? Unlike terms. So when can I add it? If they are like terms. Likewise. Can I add this and that together? No. Why? Because that is not the same. You understand, people? If the sum was 1,05 x to the minus 2 plus 3,8 x to the minus 2, what would that be? That's going to be 4,85 x to the minus 2. Why? Because when we're adding and subtracting, the variables stay the same. Can you see that, people? Adding and subtracting, the variables stay the same. But when we're adding and subtracting, the variable must first be the same. Not so for it to be like this. Now with that in mind, that means to say I must either get this as x to the 10 to the minus 3 or this as x to the minus 2. One of the two. Before I can add and subtract. Okay. So what I'm going to do is I'm going to keep the first and change the second. So that's going to be 1,05 times 10 to the minus 2 plus 3.8 times 10 to the minus 1 times 10 to the minus 2. Why did I do that? Because I know that that's going to be my like in other words my variable, or that's going to be the same. You guys understand? So we will now say that's 1,05 times 10 to the negative 2 plus. Now if I take this into account, what's going to happen? The comma must move 1 unit to the move 1 unit to the left. Okay? So that would simply be 0,38 times 10 to the negative 2. Okay. So in other words, this would now look something like this to us. It would now look like 1,05 times 10 to the minus 2 plus 0,38 times 10. Sorry man, why am I using 10? I'm writing the same thing. 0,05 x minus 2 plus 0,38 x minus 2. Can you see that, people? Can you see the resemblance? So this would be 1,43, I think, x to the minus 2. You guys see that? So now what can this be, people? This would simply be 1,43 times 10 to the negative. There we go. Okay. Alright, so for homework, you're only going to do, as I said, the first part. So out of exercise 4, you're going to do numbers 1 and 2, and then the next day's homework is going to be number 3. Okay, so we're going to first mark 1 and 2 before you do number 3. Okay, but as I said, for the purpose of the video, we're going to condense it and make it 1. Alright. Also, the full lesson can be found in the description box below. Alright.